Hi, welcome to the 9th in the Python Millionaire Retirement Simulator series. Man, if you stuck around this long, you have problems. But hopefully you're in it to find something out, and maybe they've been interesting. That'd be great. Last time we were able to make plots of 100 out of our 1,000 simulations, and now we're going to keep track of the final results. To do that, we need to make a little bit of a change. So where we have money and dates, we were just resetting these to 0 every single time we ran. And it turns out you can't, if you do that, that works fine for what we did last time, but it won't work if you want to keep track of what was your final money value or at the end of the simulation. So what we're going to do is we're going to create a list of lists, and then we're going to be able to save those lists so that they don't get blown away and they're individual for every simulation we do. So we have this number. We're going to copy these from up here, or actually we're going to cut them and put them underneath here because we're going to need to use this in sims, the number of sims. And what we're going to say, this will be confusing perhaps, but you'll make another set of brackets, and you're going to say brackets for x in range in sims. What are we doing here? What we're saying is we want a list of empty lists to the tune of whatever the number of simulations we're going to do are. Okay, and we want the same size for the money and for the dates, and that just keeps everything very even, so that when we plot things, we have the same number of data inside of our list for the money and for the dates. So we want to also get rid of these because they will confuse the issue. So we can just delete those. So now we have money and dates defined as a list of empty lists, and we want to fill them up. So everywhere we had money, we need to put money bracket sim, because sim is our caller. So basically we're saying the money in this simulation number 0, 1, 2, 3, 4, etc., append the current retirement amount. Similarly for the dates, we want to make sure that we're just recording them now for each individual simulation. And now this we need to, anywhere we've used money and sim dates, we need to make sure we put the right syntax. So here in the plot, we want to plot dates and money, etc. Okay? I hope that makes sense. So I think so far we haven't done anything that would make, this was our old plot, we haven't done anything that would make that change too much. So we can see we're still kind of have the same behavior that we saw last time. Everything is going as we expect. And so that's good news. Nothing to fear so far. Nothing has broken. We're going to let this run all the way through. All right, that's it. Great. But now that we're keeping track of our money, and we didn't blow it away every time, we kept it, we'd like to actually see what our money looks like at the end of our simulation. So down here at the bottom, after our print statement, and in fact, we may want to, I'm going to go ahead and quiet. I'm going to put a comment here for this print statement just so that it'll run a little bit faster. It's always going to run faster when you omit or remove print statements. We want to now make a new variable we're going to call final amounts as an empty list, and then something called average amount. An average amount we're going to define using something in NumPy called NumPy mp.zeros. It's just going to be a NumPy array. We're going to say shape equals the length of our dates, where this is the dates, and we're just picking dates 0 because we just need the length of any of our lists of dates. All of our dates should be the same, and we probably could get away with not having a date variable for everyone, but it's not that expensive computationally as far as I can tell. So I'm just leaving it like it is. And so all this does is it gives us a list full of zeros. And you'll see why we want that later. So then after we do that, we say for sim in range in sims, we are going to just loop through our number of simulations again. And we want to fill up this final amounts with something. So final amounts, we want to fill up with the simulation, so the money from our simulation. And if we use -1, that gives us the very last value. The very last value was the value that we ended up with in retirement at that date. So we're going to keep track of the final amount, and that's what that is, the final amount. Then we're going to do a little trick here. We're going to take our money sim, and we're going to convert it by using this equals. We're going to say it equals a NumPy array of itself, money sim. And the reason we're going to do that is because then we can do this. We can take our average amount, which is full of zeros, and we can use the plus equal architecture. But when you use it to a NumPy array, instead of it, what it does is it just adds the list like array wise. So this list of money.sim is going to be a list of numbers, all the money we had in retirement from our first paycheck until our last paycheck, and it's going to add that to our list of zeros. But to get the average amount, we'll need to divide it by the total number of simulations. And so we're going to add to that money sim that's divided by n sims. And that's another feature of these NumPy arrays, is that if you just divide them by a constant, a scalar number or a constant, it's going to divide every number in the array by that number. So this is just a fancy way in one line to compute the average in this loop that we're doing here. And so now that we've done that, we kind of want to plot these things. And so we're going to, here at the end, make use of our big plot structure where we've now populated 2 of the panes. We're going to populate a third one, and we're going to put the average amount on our second one. Hopefully that all makes sense. Our second one is axis 0, 1 dot plot. So that's where we're going to put our average plot. We want to use dates 0. We could use any of the dates because they're all the same dates. And then average amount is the thing we actually want to plot. To make this distinct, we're going to give it some characteristics. We're going to say line width equals 3. Line style equals dash dash. And color equals K. Just to be complete, we're going to give it a label. Label equals F. We're going to use an F string here. And we'll say retire. And we're going to use, what are we going to use? Today's date dot year. So that's just going to show the year, not the whole date, but just the year that we are retiring in as the label. And I think I didn't spell label right. I did not. So label. Okay. So we made that plot. To show the label, we need to do axs01 dot legend, open close parentheses. And then to use a new plot, we'll say axs10. That'll be now the third one, or the second row, first column. And we're going to make a histogram there. Dot hist. And we're going to make a histogram of the final amounts. Just to give it some character, we're going to say hist type equals step. comma, label, sorry, equals an F string, and we'll just give it the same label. Retire today's date dot year. Close curly braces. Yep. And we're gonna do this as a legend as well. And so that shouldn't be dot one. Oops, good catch. Comma, comma. But this actually should be 1, 0. Okay. And then we have a plot.show down here. So that should be all good. So we save that, and we're going to test it out over here. And so we're kind of slowing ourselves down by doing all these plots, but they're kind of fun. We can change it up so that we'll just do a big splash of all the plots at the end, which is another way to do it that will, again, save some computational time. And here's our now retirement histogram. So what this is a histogram, and it's showing that there's a low probability that you'd end up with very little money, and kind of medium probability of ending up with a little bit of money or a lot of money, and then here's the most probable outcome. And so based on the bin size here, the most probable outcome was about $85,000 saved for retirement, given all of the input that we put in to begin with, which I've totally lost track of. But that, there were very few scenarios where you ended up with, 200, is that 200,000? Yeah, $200,000. So that's an interesting thing to discover, right? Some scenarios end up with $200,000. This black dash line is our average value, and you can see that it does look like a good average. In fact, it's showing about $78,000. So this is telling us that, $63,000 is or $60,000 is our most likely outcome, while our average is about $77,000. So I don't know what I said earlier. I said 80. I don't know what I was looking at, but now that I'm looking at it again, it's looking more like 60,000 is our most likely retirement outcome given all the input we gave it earlier. So hopefully this is making some sense to you. Again, if I could say it a different way, all of these values are the very last values there. We've put those into a list, and then we plot that list as a histogram, and that's this histogram here. And so it's kind of a skewed looking function. It's not symmetric, and in fact it's something that would be called, I think, a Laplace distribution, or no, I'm sorry, a Poisson distribution. Poisson means fish. It's just some French guy's last name, but it is a Poisson distribution, and it's very typically heavy-sided like this. All right. Thank you for watching and enduring all of this simulation shenanigans. And I think the next one, hopefully, would be our final simulation wrap-up. We're going to make some more use of just the fact that we've got this architecture in place. And now, once you have it in place, it's incredibly easy to make a few modifications. And now we can do some projections on what, maybe we retire in 2040. Maybe we're not ready to retire in 2030. We can set those kinds of things and let Python just show us how things change. So thanks for watching, and I hope you stick around for the next one.